All right, we're going over the chapter review for Chapter 4 out of the textbook, page 120 to 121. Be sure you pay attention, take notes, and think about how the rules are, because that's the way they will be on the rules test, right? Number 1 through 3, number 1, we're graphing inequalities on a number line. There's a rule associated with that, and that is that if you multiply or divide both sides of an inequality by a negative number in the undoing process, you have to change the less than to greater than or greater than to less than. So we have to remember that. When you multiply or divide both sides of an inequality by a negative number in the undoing process, you have to change the less than to greater than or greater than to less than. You're not going to see that modeled in this review, but you got to remember it's modeled in the post-pack. What we're going to do is solve. We've got multiplication and addition. Which one do you undo first? Addition by subtraction. So we subtract 6, we get negative 5x is equal to 20. Now we're going to undo multiplication by division. If there had been an inequality, we would have flipped the symbol because we divided both sides by negative. If you flip an equal sign, it's still an equal sign. When you divide with different signs, the answer is negative. How do you graph an equal to on a number line? Closed circle, so we're going to put the answer, negative 4, one larger, negative 3, one smaller, negative 5. To graph an equal to, it's a closed circle on the answer with no arrows. Any questions on number 1? Now we have to remember on an inequality, if it does not have the equal to line, it's an open circle and all that stuff. So there's a lot of rules on page 86 that we have to remember, a lot of examples that we have to remember, and then that one rule. All right, any questions on number 1? Number 2, when people do the ands and ors, they get to where you just go through the process, but you don't know what the rules are, and you really need to know the rules and definitions to understand it. So for number line graphs of inequalities, or means union, which means all of both, anything contained in this or that. That's why it says or. Anything in this or that, which ends up with all of both. So on number line graphs of inequalities, or means union, which anything contained in this or that, so the result is all of both. Now, what about an and? For number line graphs of inequalities, and means intersection. Intersection means what's common to both. And so we want anything that is contained in this and that. So we darken the overlapping shaded part. And we're quoting page 89, right? And so we're going to make our final number line. We're going to put the least 3 and the greatest 5. We're going to do our hen scratch work above it. X is less than 3 would be open on the 3 with an arrow to the left. Greater than or equal to 5, since it has the equal to mark there, then it will be a closed circle with an arrow to the right. The numbers get less than 3 to the left of 3. The numbers get bigger than 5 to the right of 5 on the number line. If the middle part said and instead of or, what would your answer be? It would be no solution because there's no intersection. But we're not talking about intersection, we're talking about union, which is all of both. And so we have all of the first one with all of the second one as our final solution. Don't forget to study all the exceptions to the rules. That's why we have a post-test study pack, because it's got more examples. But study it, study your book. This is just the same length of the test in the same order, but it might be an intersection there, it might be a union, it might be a normal one, and it might be one of those special cases. All right? Number 3 we call a what? It's an, what kind? We're on page 90 of the textbook now. It's called an extended inequalities. Compound inequalities joined by an and can be written as one extended inequality. When it's written as an extended inequality, it's written in order from least to greatest. Notice the negative 2 came before the 8. With the x junk in the middle, and the arrow always faces the little guy to the left. See how that's in solution set? We just don't have the solution sets there. Least to greatest, the x stuff in the middle, the arrows face the little one to the left. We want to go from this extended inequality back into a compound inequality joined by an and. Extended inequalities turn into ands or intersections every single time. How do we do that? How do we go from the compound inequality, to the extended inequality back into the compound inequality joined by an and? You read this way to the left, and when we do that, we want the 2x plus 4 stuff first, right? And then we want the negative 2 second. And since we turned that over, what happens to our symbol? It turns over with it. Do you understand how we got the left side written properly? And then we read from the middle to the right, and we want our x stuff first and our number second, which is the way it already was, so there's no need of flipping the symbol because we didn't turn anything over. Everybody see how we went from an extended inequality to a compound inequality joined by an and? Now what we must do, and I'm going to get this out of my way here, is solve each one down. We have multiplication and addition. We're going to undo addition by subtraction. We get 2x is greater than negative 6. We undo multiplication by division, and we get x. When you divide with different signs, the answer is negative. Now what about the symbol? What does the rule say? When you multiply or divide both sides of an inequality by a negative number. What did we divide by? A positive. So do you flip the symbol? No, not unless what you multiply or divide by is a negative. So the symbol stays a greater than. Then we have our and. And so we're going to solve here. We've got multiplication and addition. We're going to undo addition by subtraction. We have 2x is less than 4. Now we undo multiplication by division, and we get x is less than 2. Again, we do not flip it because we did not divide by negative. We now have a compound inequality joined by an and so we want to graph that intersection on a number line. And so we're going to put negative 3, the least, to the greatest. We're going to do our hen scratch work. How do you graph x is greater than negative 3? Open, arrow to the right. How do you graph x is less than 2? Open, arrow to the left. For number line graphs of inequalities, and means intersection, and intersection means what's common to both, and the common stuff is that in there. What is the lower limit to the intersection? Negative 3. Is it open or close? Open. What's the upper limit to the intersection? 2. Open or close? Open, and then the intersection is what's between. And so we have graphically represented that extended inequality. Everybody see how we did number 3? Now let everybody catch up on their writing, and those at home viewing can catch up on their looking at it and studying it. Okay? Any questions so far? So that was page 86 of the textbook. This is page 89 of the textbook. This is page 90 and 91 of the textbook. So we skipped page 88, which is absolute value, which is number 4. So number 4 and 5 are absolute value, which come out of page 88 of the textbook. We did this a little bit out of order so we could get all our inequalities together. Any questions so far? All right. Number 4 and 5, this comes from page 88. What do these little vertical bars mean? Absolute value. There's a 3-step process that we should have memorized to solve an absolute value. First of all, let's do the definition. Absolute value represents distance. There's no such thing as a negative distance, therefore absolute value is always positive. So the absolute value of a negative number is a positive number, and the absolute value of a positive number is a positive number. And when we're finding absolute value of a number, what are we really doing? We're telling how far that number is from 0 on the number line. We're telling how far that number is from 0 on the number line. It's distance from 0. Okay? So a negative 4 has a distance of 4 from 0. A positive 4 has a distance from 0 of 4. There we go. Negative 4 has a distance from 0 of 4. And positive 4 has a distance from 0 of 4. So negative 4, positive 4, both have a distance of 4 from 0, so they both have an absolute value of 0. Okay. Now, there's a 3-step process on page 88 to solve an absolute value equation. Number 1 says isolate the absolute value. Number 2 says write 2 equations. A, stuff inside equal positive the number. Remember, you're going to have a fill-in-the-blank rules test, right? So you have to say all this. B, stuff inside equal negative the number. And step 3, solve each one using the order of operations. There we go. So we want to isolate the absolute value. Is there anything on this absolute value? No, so we don't have to do step 1. So we move to step 2. What does step 2 say to do? Write 2 equations. Stuff inside G. That's telling you to get rid of the absolute value bars. How many of you left them on half chapter 4 test and I count them wrong? Several. It says stuff inside G equal positive the number 7, or stuff inside G is equal to negative the number. That's step 2. What does step 3 say to do? Solve each one. Is there anything to solve? No, so that's it. We still use step 1, step 2, step 3. Step 1 didn't need to be done. Step 2 we did, and step 3 didn't need to be done. But we still thought through step 1, step 2, step 3 on page 88. Okay? All right, number 5. Number 5, we want to solve this absolute value equation. Step 1 says to do what? Isolate the absolute value. Get the junk off. What junk is on it? A times 3 and a plus 6. We're not talking about what's in it. We're talking about what's on it. Now we got to get rid of what's on it to isolate it. So we got to get rid of the 3 and the 6. Which one do you undo first? The 6. You undo addition by subtraction. And we're going to have 3 absolute value, 2x plus 8, close absolute value is equal to 18. Have we completed step 1? No, we are trying to isolate the absolute value. It's still got junk on it. It's still got multiplication. What undoes multiplication? Division. And so we get 2x plus 8, still in the absolute value, equals 6. Why do we leave it in the absolute value? Because we're trying to do step 1, which says to isolate the absolute value. And so we just completed step 1. We isolated the absolute value. Now, while I'm talking about stuff, can you distribute through an absolute value? No. What is the only thing that you can distribute through? Parenthesis. You cannot try to distribute through the absolute value. Don't be trying to do that. It actually says that on page 88. Now, we have completed step 1. Now, what does step 2 say to do? Write 2 equations. How do we write them? Stuff inside. That's telling you to get rid of those absolute value bars now. Stuff inside. Let me put it over here. I want to make myself some room and do it here. Whoa, we're going haywire here. So we're going to say stuff inside 2x plus 8 is equal to 2x plus 8 is equal to 6, or stuff inside 2x plus 8 is equal to negative 6. Notice the absolute value bars are gone now. We want stuff inside. Get rid of them. All right. We've now completed step 2. Step 1 was completed right here. Isolate the absolute value. Step 2 was completed right here. We wrote 2 equations. Stuff inside equal positive the number. Stuff inside equal negative the number. Step 3 says to solve each one using the order of operations. We're going to undo. What do you undo first? Addition by subtraction. And so we get 2x is equal to negative 2. We're going to undo multiplication by division, and we get x is equal to negative 1. Or, that little or is not to be confused with an or like union. That's not a union or, right? It's just saying this is the other answer. Okay? So now we want to solve over here. We're going to undo multiplication and addition. We undo addition first. We get 2x equal negative 14. The 6 is negative and the 8's negative, and when you add or subtract with the same sign, you add and take the common sign. Now we undo multiplication by division, and we get x equal negative 7. So those are the 2 solutions to that absolute value equation. Any questions on 4 and 5? Absolute value represents distance. There's no such thing as a negative distance. Therefore, absolute value is always positive. There's 3 steps to solving an absolute value equation. Number 1, you isolate the absolute value. Number 2, you write 2 equations. A, stuff inside equal positive the number. B, stuff inside equal negative the number. And step 3, you solve each one using the order of operations. Any questions so far, 1 through 5? All right, number 6 through 8 is from page 95 in the textbook through page 97B. Actually, it's really through 97A. I guess we'll just say 97A because that's where it goes through. Although we need 97B to understand slope, but that's okay. All right. What form of a line is number 6 in? It's in slope-intercept form, which is y equal mx plus b, where m, the coefficient of x, is the slope, and b, the constant added to the x stuff, is the y-intercept. So what is the y-intercept of number 6? It's the 2. The y-intercept is the constant that's added on to the x stuff. The constant added on to the x stuff was 2, so my y-intercept is 2. What is the slope of number 6? 1/2. The slope is the number that's being multiplied to x. We call it the coefficient of x, and so the slope of this line is 1/2. Any questions on that? So we identified the slope and y-intercept. Now we want to build a table, and we're quoting page 97A. To build a table, we start with x because it is the domain or the independent variable. The rules test is exactly what I'm saying. We solve for y because it is the range or the dependent variable. What you put in the middle is what it says, and it says that y is equal to 1/2 x plus 2. If the slope is a fraction, then choose multiples of the denominator for x. So we're going to choose multiples of 2. So we're going to use -4, -2, 0, 2, 4. We want some negatives, 0 and positives, but we want multiples of the denominator if it's a fraction. What does the 0 give us when we build our table, 0 for x? That's the y-intercept. The y-intercept in the table is the value of y when x is 0, remember. So we're going to plug these numbers in. We will have 1/2 times x, which is -4 over 1 plus 2. 1/2 times our new x, -2 over 1 plus 2. 1/2 times the next x of 0 plus 2. 1/2 times the next x of 2 plus 2. And 1/2 times 4 plus 2. Yes. Yes. Now, we've got multiplication and addition. Which one of those do you do first? Multiplication. So we're going to cross reduce. 2 will go into 2 once. 2 goes into -4, -2. So we're going to have 1 times -2 is -2, plus that 2 is a 0. Understand that? And then we've got 2 goes into 2 once, 2 goes into -2, -1. 1 times -1 is -1, plus that 2 is a +1. Sign rules. Anything times 0 gives you a 0, and 0 plus 2 is 2. These 2's cancel. You have 1 plus 2 is 3. 2 goes into 2 once, 2 goes into 4 twice. 1 times 2 is 2, plus 2 is 4. Now you don't have to write these ordered pairs, but we want to make sure that everybody understands that what we just did was found 5 what? Ordered pairs, but we call them what else? What are we trying to do here when we graph? Show you the what? Solution set. We're looking for solutions, right? We just found 5 points, or 5 solutions to this linear equation. How many solutions does this linear equation actually have? An infinite set. What graphically represents the infinite set of solutions? The line. That's why it's got arrows on both ends. There's an infinite set of solutions. The line itself is a solution set. So we're not just randomly doing this stuff to look cool. We're actually trying to take an equation and show visually all of its solutions. Okay? Now, there's 2 ways that we could graph. We could plot those points, or we could use the slope and y-intercept. If we plotted the points, then this point would be -4, 0, to the left 4, up or down 0. The second point was -2, 1, to the left 2, up 1. The next point was 0, 2, to the left or right 0, up 2. That's the y-intercept. 2, 3 is to the right 2 up 3. 4, 4 is to the right 4 up 4. Did I mess up somewhere there? No. 4, 4. To the right 4. I just wasn't going far enough. Up 4. And you could draw a line through that. But how else could we come up with the graph? We could use our slope and y-intercept, right? We'll do that in blue. What's the y-intercept? 2. That tells me that it crosses the y-axis at 2. From there we could do what our slope says. Our slope is change in y over change in x. When y is positive, you go up 1. When x is positive, you go right. So that means up 1, right 2. So from the y-intercept, we could go, up 1, right 2, up 1, right 2, up 1, right 2. So we can either plot the points and draw a line, or we could use the y-intercept and slope and draw a line. Either way, we get the same line. Don't forget that the line with arrows represents the infinite set of points that make that true. You can pick any point on that line, take its x and y, plug it in, and it'll come out true. Any questions on number 6? Okay. Number 7 leads us into some special stuff that we've got to remember from page 96 and 97. From page 96 and 97. Let me just get all that out of the way. A y only. As soon as you see y only, your brain goes into memory work gear. Y only is a what kind of a line? Horizontal. What is the slope of every single horizontal line? 0. And what is the y-intercept? The constant y value 4. What if it was an x only? Vertical line. The slope is undefined on a vertical line. And the y-intercept? None, because it is parallel to the y-axis. When you build it, do what? Yeah, I want the right word. I want undefined when it's undefined and none when it's none. Don't switch those words. Correct. Yeah, don't switch those words. I want undefined and I want none. All right. When we build a table for horizontal and vertical, we do not need a middle section because y is not dependent on x. Y is, you were right, say it again, constantly 4. So y equal 4 saying y is constantly 4. It don't matter what you plug in for x, you're going to get 4 for y. Therefore, you don't need a middle section in your table. We just need some x's to go with those y's, so we're going to make up our old faithful ones, so negatives, 0, and positives, small as we can get, -2, -1, 0, 1, 2. We really don't need those points to graph with. We just wanted you to see the constant y in the table. To graph, all we need to do is make enough ditto marks to get out to where we need to be. It's a what kind of a line? Horizontal through y is 4. Where's y 4? Up 1, 2, 3, 4. And it's a horizontal line through that. Mine kind of sagging there. Any questions on number 7? You need to do your horizontal and vertical memory work. Good place to study that. Page 96 at the bottom, 97 at the bottom, or page 104 at the top. 104 at the top has slope intercept, point slope, horizontal and vertical all together there. Good place to study that. Any questions so far? Okay, number 8. Number 8, what is the slope? The slope is the coefficient of x. And so my slope is -3/4. The y-intercept is what's being added on to the x. It is that constant that's being added on, and so my y-intercept is 3. I just see how to name the slope and the y-intercept from the equation. So now we want a table. To build a table, we start with x because it is the domain, or the independent variable. We solve for y because it is the, or the dependent variable. Is the range or the dependent variable. What goes in the middle is what it says, that y is equal to, and it says that y is equal to negative 3/4 x plus 3. Now we're quoting page 97A, right? If the slope is a fraction, then choose multiples of the denominator for x. So we're going to choose some negative, 0, and positive, but we want multiples of 4. 4, 8. So we're going to use negative 8, negative 4, 0, because that gives us our y-intercept, and then we want a 4 and an 8, positive. Understand that? We plug them in. We get negative 3/4 times x, which is negative 8 over 1 plus 3. Negative 3/4 times my second x of negative 4 over 1 plus 3. Negative 3/4 times x, which is 0 plus 3. Negative 3/4 times x, which is 4 plus 3. Negative 3/4 times x, which is 8 plus 3. Just getting it written, right? The hard part's doing it. Knowing how to do it, simple once you know how to do it. Kind of washing dishes. Once you learn how, it's not knowing how to do it anymore, it's the doing it. All right. But you got to kind of learn some of that stuff. All right, we're going to multiply, and then we're going to add. And so 4 going to 4 once, 4 going to negative 8, negative 2. Don't forget that negative. So we have a negative 3 times a negative 2, which is a positive 6, plus 3 is 9. Understand that? Just be careful with your signs. 4 goes into 4 once, 4 goes into 4, negative 1. Negative 3 times negative 1 is positive 3, plus 3 is 6. So anything times 0 is 0, plus 3 is 3. 4 goes into 4 once, 4 goes into 8 twice. Negative 3 times 2 is negative 6, plus 3 is, I missed one, negative 3. I did the 8 bottom one instead of the middle one. I missed the 4. So we'll go back and get it. That messed up what you were saying, didn't it? I was thinking about what you were saying. I jumped down there. 4 goes into 4 once. 4 goes into 4 once. Negative 3 times 1 is negative 3. Plus 3 is 0. So what he was saying was that once you do it a little bit, you notice it's gaining 3 every time, so you can just kind of chuck them in there and quit figuring. Okay? I think that's what he was saying. Anyway, any questions on how we built the table? We want a graph. I'll just draw my own little grid here right quick. Whoa. Maybe I shouldn't. We'll just drag our own little grid in here right quick. We want a graph using the slope and y-intercept. What was the y-intercept? So it crosses the y-axis at 3. The slope of negative 3/4. That's not good. The slope of negative 3/4 means to go down 3 because the top is changing y, and where y is negative, you go down. And the 4 means to go to the right 4. So my slope of negative 3/4 means to go down 3 right 4. So I'm going to go from my y-intercept, down 3, right 4, make a dot, down 3, right 4, make a dot, down 3, right 4, make a dot, and draw my line. Remember that lines that have negative slopes lean to the left. Lines that have positive slopes lean to the right. All right, any questions on 6 through 8? Yeah, that's pretty neat, isn't it? Pretty neat. Any questions so far? Yes. Okay, let me see if it'll come back. Didn't come back. So we had negative 3/4 times what?
You would hit it one more time.
Would it? I'm sorry. Negative 3/4 times what was it? 4 over 1? Is that what it was? Oh, the 6 was on the bottom. The 4 turned into a 3. If we plug in a 4, those cancel. We get negative 3 plus 3 is 0. Did I make a mistake somewhere? No, I'm not sure now because it's all kind of, we don't have the right thing there.
It's right.
Okay. Don't know. I'll help you in a minute. I'm not sure. It's gone, so I don't know how to get it back. All right, let's go to the next one, and I'll check that out later. Okay, we need to go to the next page. The next page obviously is in another section because there's not an arrow that lets me go to the right. So I need to downsize and come back up. I'm going to have to go to and pull it up. Transparency model 2. Wait, I want 3. 3. There we go. It was on another set of scans. Okay, here we go. Page 121. I'll answer later too. Page 121, it says write an equation that would represent each table. And this is on page 97A. It's also on page 101. Yes, and we can do them on the calculator, but we want to learn how to do them on paper first. We want to write an equation. What form are we going to put it in? Slope-intercept, which means we need to find what two things? Slope and y-intercept. How do you find the slope of a line from a table? To find the slope in the table, you find the change in y over change in x. Between any 2 points, what's the change in y between the first pair of points? It's a gain of 3. What's the change in x? It's a gain of 2. The change in y over the change in x is a 3 over 2. Now, it needs to be consistent all the way down through there, and you can see that it would be 3 over 2, 3 over 2, 3 over 2, 3 over 2. So it has a constant rate of change. Therefore, it's linear. That's our slope. What's the y-intercept in the table? The y-intercept in the table is the value of y when? X is 0. So that first point, 0, 3, is my y-intercept. So my y-intercept is 3. So I want to write an equation. My equation would be y equal slope 3 over 2 x plus y-intercept 3. Any questions on number 9? That's it. It says write an equation that would represent each table. we needed a slope and a y-intercept. We calculated the slope, change in y over change in x. The y-intercept in the tables, the value of y when x is 0, it was there, so we didn't have to do any calculating to get it. Once we identify them, we plug them in, and that's it. Any questions on number 9? Number 10. Number 10 is the same kind of deal. We're on page 97A, page 101. We want to write the equation of a line in slope-intercept form, so we need to find the slope and the y-intercept. To find the slope from the table, you find the change in y over change in x between any 2 points. The change in y from the first point to the second is a gain of 2. The change in x from the first point to the second is a gain of 4. We put the change in y2 over the change in x4, and we reduce it to 1/2, so there's our slope. Understand how we got the slope? The y-intercept is the value of y when x equals 0. X equals 0 is not in our table, so my y-intercept is missing. So I'm going to have to calculate it. How do I calculate the y-intercept? You're going to pick a point from the table. If we use the first point, it's negative 2,5, and the slope that we've come up with, 1/2, and we're going to plug those into y equal mx plus b, using that as a formula to solve for what we're missing, b, the y-intercept. So we're going to take the y of the point and put it in place of y, 5. Slope, which is m, and put it in place of m, 1/2. The x of the point, and put it in place of x, negative 2 over 1, plus b. The only thing left is b, which stands for y-intercept, so we can calculate the y-intercept. To do that, we're going to do anything we can to simplify first. 2 goes into 2 once, it goes into negative 2, negative 1, so we get 5 equal negative 1 plus b. We want the junk off of b, so we're going to add 1 to both sides. And we get b equals 6. So there's your y-intercept. We have identified the slope and the y-intercept. We're going to write that in slope-intercept form, y equal mx plus b. We insert the slope for slope, the y-intercept for y-intercept, right? Y equal mx plus b. So my equation is going to be y equal 1/2 x plus 6. Any questions on number 9 and 10? Yes. If they're inconsistent, then let me show you. If you did the second change in y, this would be a gain of 4. Change in x is a gain of 8. 4 over 8 is still 1/2. So there is consistency in change in y over change in x. If that wasn't the case, it would not be linear. All right, we'll stop right there and pick up with number 11 tomorrow. Thank you. Yeah, y'all do good.